Our theorem is very easy theorem. If AB is relative prime, what it's mean? There is no greatest common divisor of both numbers other than 1. If two numbers have greatest common divisor 1, then these two numbers are called relative prime. Then we have to prove this, that GCD of adding these two numbers and subtracting these two numbers is 1 or 2. If this, we can understand by a simple example. I have two numbers having GCD 1. Okay. Then we have to prove that 5 plus 6 and 5 minus 6 have GCD. This is 11, this is minus 1, GCD 1. Okay. Or if I have 3 and 7, for example, then 3 plus, then also they are relative prime, then 3 plus 7 and 3 minus 7, what I have 10 and minus 4 have GCD 2. Okay. Then if I have two numbers relative prime, then their addition and subtraction having GCD 1 or 2. We have to prove this. Okay. It is given that solution given that A and B are relative prime having GCD 1. Okay, then we have to prove GCD of A plus B and GCD of A minus B is 1 or 2. We have to prove this. Okay, we suppose that this GCD is D. Now we have to find out the value of D is 1 or 2. What is our what will be our answer? The value of D is 1 or 2. We suppose this GCD of A plus B and A minus B is 2. For example, I have 4 and 6 and their GCD is 2, for example. Then 2 must divides 4 because it is greatest common divisor of this, and 2 divides 6. Okay, therefore, which implies D divides A plus B and D divides A minus B, just like that. Okay, if 2 divides 4, then 4 can be written as 2 multiply 2. Multiply with any number because this is multiple, this is divisor, this is divisor, and this is dividend. So I can multiply with something that it is equal to this thing. Okay, and this is multiple, this is factor must be multiplied with anything that I have answer 6. I can name these two values C1 and C2. If D divides A plus B, then A plus B must be equal to C1D and A minus B must be equal to C2D. These are two factors of the, because this is divisor and this is multiple must be equal to two factors. Okay, this is number 1. Give it number 1. Give this equation number 2. So by adding 1 and 2, also by subtracting 1 and 2. Okay, if I add A plus B is equal to C1D, A minus B is equal to C2D, plus B and minus B should be cancelled. A plus A is 2A, and this C1D plus C2D, I add this. Okay, what is common in both terms? D is common. So what I have the answer, I take common D to I want the value of A, so I divide with 2 on both sides. What will be A? Therefore, A is equal to C1 plus C2 over 2 into D, and B is equal to C1 plus C2, no, minus over 2 into D. How this come? How this come? By subtracting this. Okay, I show you. A plus B is equal to D. A minus B is equal to this A plus B is equal to C1D, and A minus B is equal to C2D. Okay, when I subtract, changing the sign of this, plus minus, okay, this is plus, this is minus, A will cancel, AB plus B, 2B is equal to C1D minus, okay, C2D. What is common in both terms? C1 minus C2D is common. I want to find out the value of B. Then what will be B? C1 plus C2 into D. Okay, this is B and this is A. Now I have two cases. Case first. I have C1 and C2 two numbers, and from here you can see that C2 and 3, 2 and 3, they are relative prime. It is must that you take any two numbers, 3 and 9, you take having GCD 3. Okay, 3 divides 3 and 3 divides 9, then 3 is equal to 3 multiply 1 and 9 is equal to 3 multiply 3. Then these two numbers must be relative prime. Okay, then I can write here where C1 and C2 are relative prime. From this expression, I can give here two things. If these two are relative prime, then both are odd, just like that. Okay, both are odd and one is odd and one is even. If their greatest common divisor, only two cases we have, both C1 and C2 are odd. What happened when both C1 and C2 are odd? For example, just like that, 5 plus 7, what it comes? 12. Then if it is divided by 2, then answer will be 6. Why I am doing this? Because I have A here and these are two factors. I have in denominator here too. Maybe I have a doubt that if 2 divides 11 must be 5.5. So I have to prove this, that this is integer. I have to prove that this is integer. I see here, I take an example of two odd numbers having greatest common divisor 1. Then if I divide their sum by 2, 12 by 2, 6, I have integer. If I take difference of these two numbers, 5 minus 7 by 2, it is minus 2 by 2, then I have minus 1, an integer. Both are odd, then C1 plus C2 by 2 and C1 minus C2 by 2 are integers. If they are, what it's mean? It's mean this is also integer, this is also integer. So these both are factors of A, which implies D divides A and D divides B. And because A and B is relative prime, we see here A and B is relative prime. What it's mean? D is divisor of A and B, means common divisor of A and B. So D divides greatest common divisor 1, which implies 1 has only two divisors, plus 1 and minus 1. So D value is plus 1, and as D is greater than 0, as D is greater, so D, what will the value of D? D is equal to 1. Okay, what it's mean? Put the value of D here, A plus B and A minus B is equal to 1. We get one answer here. Now the case second, I suppose here C1 and C2 both are odd. If both are not odd, both are one is even. Why? If here two cases, because C1 and C2 are relative prime. So relative prime means one case is both are odd and one case is C1 is even, 1 is even. Case second. What is case second? 1 is even and other is odd. Okay, 1 is even, for example 5 and 6, 1 is even and other is odd, then their difference must be odd number. Addition and difference, then their addition must be odd numbers, and if they are odd, so C1 plus C2 by 2 is not an integer. Why? Because if their sum is odd number, if divided by 2, I have in decimal, but in number theory we haven't any decimal number or fractions. Okay, so what is our conclusion? If one of C1 and C2 is even and one of C1 and C2 is even and other is odd, then this must be even, okay, because these are two factors. This could not be in decimal, so 2 must be under the D. Okay, and in case of B, C1 plus C2, 2 must be under the D. These are two factors of A. What it mean? D by 2 divides A. Common divisor of this is multiple, and these are two factors. Factor divides the multiple, and D by 2 divides B. Okay. And what is GCD of A and B? Where? 1. AB GCD is 1. So if D is common divisor of A and B, dividing both A and B, then D by 2 is common divisor of A and B, then d by 2 must divide greatest common divisor, and one have only two divisors, plus 1 and minus 1. So d by 2 have only two values, plus 1. And as you know that if d is GCD, then it should be greater than 0. So d by 2 must be greater than 0, could not be negative. It means d by 2 is equal to plus 1. If I multiply 2 here, okay, then what will be the value of d? 2. If I join this result and this result, plug in the value of d from here, d is equal to 1 and d is equal to 2. How can I write this equation? A plus b and a minus b is equal to 1 or 2. I have proved this. If you are given that AB is relative prime, then prove this. This is not given. Then you have to first prove this, then go to this proof. How? I have to prove this thing. So consider A plus B, A minus B and AB. Okay, I say left hand side of this. I can write it as A plus B and A minus B GCD and AB GCD. Okay, if case first, if as I have A and B is relative prime, there is greatest common divisor of A and B is 1. It is given that greatest common divisor of AB. Then I have two cases, both A and B are odd. If both A and B are odd, then their addition and subtraction must be addition of two numbers, odd numbers, and difference of two odd numbers is even. Then their greatest common must be even, and we have answer of this two, A plus B and A minus B is 1 or 2. If both are odd, then it must be 2, because this is even and this is even. If A and B both are odd, then their addition must be and subtraction must be even, and GCD of two even numbers are 2. Therefore A plus B and A minus B GCD from 1 and 2, we decided it is 2. And when both are odd, then their multiple must be odd. If I multiply 3 multiply 5, 9 multiply 3, multiple of two odd numbers must be odd. So this is odd. If A and B, A is also odd, B is also odd, then their multiple must be odd. Then GCD, greatest common divisor of one even and one odd, 2 must be 1. Okay. Case second. If both A and B, if one is even, case second, one is even and other is odd. Why? Because AB is relative prime. greatest common divisor of A and B is 1. It is given that. Then next case is, one case is both are odd, one is even and other is odd, just like that. Then their sum and their difference is odd number and having greatest common divisor odd. We have here two answers of these two numbers, 1 or 2. If both are odd, a plus b and a minus b are odd, then answer must be 1. Their answer must be, therefore a minus b, a plus b, therefore, and a minus b must be 1. So a plus b, consider a minus b and ab is equal to a plus b. I can write it as this. GCD of this is equal to GCD of this. This GCD I have calculated 1 and AB. When 1 is even, A is even and B is odd, and other is odd. Okay, if one is even and other is odd, their product, one is even and other is odd. The product is even, one is even, other is odd, then their product is 30. 30 is even. So the GCD of one and even number must be 1. So we have proved this. GCD of A plus B, A minus B and AB is 1. We have proved by this and these two cases.